You probably wouldn't expect NASA to have anything to do with firearms, but space tech and weapon development have more in common than you'd think. Some of the most powerful guns and high-tech projectile weapons out there today owe something to NASA's breakthroughs in propulsion, energy storage, and aerodynamics. Wondering which ones? Well, stick around, because in this video, we're diving into 6 weapons that wouldn't exist without space-age science. From electromagnetic railguns to rocket-powered pistols, these designs push the limits of what's possible, and they might just be a glimpse into the future of firepower. Some are still experimental, while others are creeping closer to real-world viability. And who knows, the next breakthrough in small arms might come straight out of NASA's playbook. Electrothermal chemical, or ETC guns. Firearms keep pushing the boundaries of power and efficiency. As we look at older black powder muskets, then at modern rifles, we see a steady climb in muzzle velocity and accuracy. Some might think we're nearing the end of the road, but ETC guns suggest that there's more ground to cover. They use a plasma-based ignition system that supercharges the combustion process, so we get higher velocities with less wear on the barrel and more consistent shots. They've been tested on large caliber platforms like tank guns, but the concept could trickle down to small arms if battery and capacitor technology become compact enough. NASA might not be designing rifles, but their research into advanced propulsion systems influence all the breakthroughs in ignition and energy transfer. The idea of using electricity to kickstart a more controlled burn stems partly from the same mindset that drives rocket scientists to optimize every ounce of fuel. ETC works a bit like having a tiny rocket boost inside each cartridge, only it's all happening in a closed chamber. Engineers have tried these systems in tank prototypes, but miniaturizing them for something you can carry around is the tricky part. Imagine the challenges. A soldier or private citizen can't haul a huge power supply for every shot. That's where future tech from NASA and the aerospace world may help, because they're already working on batteries and capacitors that deliver maximum power in small, lightweight packages. If those breakthroughs continue, you could someday have an ETC-powered rifle that uses a fraction of the propellant and still hits harder and more reliably than conventional weapons. For now, ETC firearms remain in the research phase, and unfortunately, there aren't any ready for daily carry. Still, the improved ignition control they offer is hard to ignore. If you're into ballistic tech, ETC promises a leap forward that blends electrical energy with chemical combustion. It's not just about going faster, it's about doing it more efficiently and consistently. Think of it as one more chapter in the ongoing story of modern firearms. A chapter NASA helped write in its own indirect but meaningful way. Gauss rifles. One look at the Arc Flash Labs GR1 Anvil and you'd immediately think it belongs in a sci-fi movie, but it doesn't. It's a coil-driven rifle that accelerates steel projectiles using electromagnets, not gunpowder. This design depends on batteries and capacitors to deliver a series of magnetic pulses, pulling the projectile down a smooth barrel. The GR1 Anvil is only in its early stages, but it proves that coil-based firearms are more than just a fantasy. NASA's own pursuit of electromagnetic launch systems has helped to refine certain aspects of energy storage, which plays directly into how Gauss rifles work. Even though NASA focuses on sending satellites into orbit, their experiments in electromagnetic rail technology and power management inspire civilian inventors to apply those lessons to small-scale arms. The GR1 shows that if you have a strong enough power supply, you can launch a steel slug at decent speed without any gunpowder at all. Handheld coil guns still face big hurdles. They rely on bulky batteries and capacitors, so the gun ends up heavier than the typical rifle and nowhere near as powerful as a standard AR or AK. You also get a slower projectile speed, so right now they're in the same energy range as a .22 or a little lighter. But if you think about how rapidly battery technology is evolving, it's not crazy to picture a future where you have a coil rifle that's just as handy as your favorite carbine. The GR1 anvil needs careful handling because it creates strong electromagnetic fields, which can interfere with sensitive electronics or medical implants. Now, that's a serious concern, but it might become less of an issue as engineers refine coil designs and shielding methods. If improvements in power storage keep rolling in, you may see a Gauss rifle that's compact enough for a serious range session or a specialized military role. NASA's indirect influence is there. It pioneered some of the electromagnetic concepts that make devices like the GR1 possible. Now we're going to take a second to remind you to like, subscribe, and to share the hell out of this video. Your views, likes, and subscriptions are the reason our team can bring you human-created content for the weapon enthusiast, homesteader, prepper, but also just to the everyday guy wanting to get prepared. Without you, we couldn't do what we do. So to those of you who have already subbed, and to those of you who are about to do just that, thank you. Coil guns. If you're wondering how coil guns differ from Gauss rifles, they're basically two sides of the same electromagnetic coin. Arc Flash Labs' EMG-02 is a refined take on what a small portable coil gun can do. Instead of using separate capacitors for each coil, it manages one large capacitor that discharges through multiple coils in sequence. That approach gives you a steadier shot and slightly higher speed, though it's still not on par with typical chemical propellants. NASA's influence shows up in how engineers optimize power consumption and coil efficiency. If you read about NASA's electromagnetic launch experiments, you'll see parallels in how these coil guns are designed. The very same principles that help fling payloads without chemical rockets also guide the shaping and firing of ferromagnetic slugs. It's all about controlling the timing and power to get the best acceleration while managing heat. The EMG-02 is smaller and a bit more practical to handle than some earlier coil guns, but you'll find that the projectiles travel slowly enough for you to see them in flight, which isn't exactly ideal for real-world defense or combat. Still, it's a big improvement from earlier designs, thanks to changes in capacitor technology, coil arrangement, and overall ergonomics. The next big step would be to boost muzzle velocity without making the gun too bulky. If you want to know whether coil guns might replace your AR-15 or bolt-action rifle anytime soon, the short answer is no. Like the Gauss rifle, coil guns still need major leaps in battery capacity, heat management, and projectile design. But if you're into forward-thinking tech, coil guns are a glimpse into how electromagnetic propulsion could become viable in smaller arms. Now, NASA isn't handing out coil gun patents, but the knowledge base from space launch research helps tinkerers figure out how to manage large electrical currents in short bursts. That's a big reason that coil guns are inching closer to being more than just lab experiments. Railguns. Have you played a few of those futuristic or post-apocalyptic first-person shooter games? Well, if you have, you've probably heard of railguns too. Much like Gauss rifles and coil guns, railguns might look fictional, but they do exist in real life, in experimental forms at least. They launch conductive projectiles by running huge currents through parallel rails, creating electromagnetic force that sends the rounds zipping out at hypersonic speeds. Unlike a traditional rifle, there's no powder or primer, just a massive jolt of electricity. The US Navy has shown off prototypes capable of extreme velocity and range, although they're still trying to solve barrel wear and huge power requirements. NASA doesn't build warships, but its work on electromagnetic launch systems and advanced materials that has a ripple effect in railgun development. NASA researchers studied how to fire payloads into orbit using electromagnetic propulsion. So they needed to figure out how to handle scorching temperatures, high-speed friction, and enormous power demands. That very same know-how helps the military refine rail materials and energy management solutions. The sheer speed of a railgun round gives it devastating impact. You don't need an explosive warhead because the kinetic energy alone can smash through targets. That's one reason railguns look so attractive for long-range engagements. A typical ballistic shell can curve off course or slow down significantly, but a railgun projectile travels so fast it's harder to intercept and hits with tremendous force. The biggest obstacle to a hand-carried railgun is, you guessed it, batteries. It has the same problems as Gauss rifles and coil guns. We're talking about megajoules of energy in a fraction of a second, which is something no ordinary battery can handle. Now, if you're hoping for a backpack railgun in the near future, you'll be waiting quite a while. Capacitor and battery tech would have to advance way beyond where we are now. Still, the concept has NASA's fingerprints on it, and the incremental breakthroughs in power storage are helping railguns inch closer to practicality. They're probably going to stay on ships and labs for quite some time, but you never know how fast technology can evolve once a few key puzzles get solved. Hypersonic and high-velocity projectile weapons. When we hear the word hypersonic, we immediately think of sleek aircrafts or missiles zipping through the sky faster than Mach 5. But these ideas can also apply to big artillery shells or smaller projectile weapons that rely on advanced propulsion and special materials. A hypersonic round hits so quickly that reaction time on the receiving end is practically zero. That's why militaries are interested. A weapon like that is tough to detect or stop. Now, NASA's role here is easier to see because they have long studied how objects move at high speed through the atmosphere. When you send a space capsule back from orbit, you need to understand high-temperature shock waves and how to prevent meltdown. That research trickles into hypersonic weapons design, where you have to manage extreme heat, structural integrity, and aerodynamic stability. The rocket scientists have given the defense world a treasure trove of data on how to handle speeds that can reach Mach 7 or more. Now, it might sound counterintuitive that hypersonic rounds don't rely on huge explosive warheads, as they are designed to destroy targets through raw speed and mass. But think of a meteor striking the Earth. It doesn't explode chemically, it just obliterates things with sheer kinetic force. If NASA can test how satellites and capsules behave at re-entry speeds, the military can apply those principles to bullets, artillery shells, or glide vehicles that travel a similar velocity range. If you're wondering about household hypersonic guns, that's not happening anytime soon. The heat and pressure at those speeds would tear apart typical materials, and you'd need a launching mechanism that's more like a rocket or rail system than a standard rifle barrel. Hypersonic projectiles are more useful in artillery, missile technology, and possibly railguns. For a personal weapon, you'd have to shrink rocket science to fit in your hand, which is still beyond our reach. Then again, technology keeps marching on, and NASA's continuing work on advanced propulsion might open doors you'd never expect. Rocket-propelled guns. You've probably run across stories of the Gyrojet pistol online if you like weird guns. It was developed in the 1960s to fire rocket-propelled rounds. Instead of a bullet pushed by gas pressure in the barrel, each projectile carried its own fuel and kept accelerating even after it left the muzzle. It sounds like a great idea. Lightweight gun, minimal recoil, and decent stopping power. But the reality was a little disappointing. The rounds took a bit to speed up, so you lost close-range effectiveness. And accuracy wasn't great because the rockets spun themselves rather than riding rifling. NASA didn't directly build the Gyrojet, but their exploration into small rocket motors and high-speed impacts definitely fed the broader knowledge base. NASA's work on micrometeoroids and mini propulsion systems influenced how engineers thought about tiny rockets. The Gyrojet tried to capitalize on that rocket science, but the tech just wasn't mature enough to be consistent. You'd get misfires, poor accuracy, and production costs that made traditional firearms look cheaper and more reliable. Years later, people tried to improve on the Gyrojet concept. They experimented with bigger calibers, better nozzle designs, and advanced fuel formulation. Some took cues from NASA's rocket materials research, using stronger metals or ceramic coatings to handle heat and pressure. These newer prototypes fired more efficiently and reached lethal velocity sooner. You still run into the same problem though. If the round needs time to accelerate, it's not very effective at close range. That's a big downside for any personal defense or military application. The gyrojet taught us an interesting lesson. Rocket propulsion can work in handheld weapons, but getting it to match or beat standard firearms is a tall order. We need a stable ignition system, robust materials, and a rocket motor that ramps up velocity fast. Even if we solve those issues anytime soon, the cost and complexity might outweigh the benefits. But it's still a cool idea that merges NASA-inspired rocket tech with firearms, and maybe future breakthroughs in micro-rockets or guidance systems will spark a revival. But for now, the gyrojet remains a curious weapon that hints at what could possibly happen if rocket scientists really doubled down on small arms design. And those are 6 pieces of NASA's secret tech that influenced firearms and weaponry as we know it. Granted, some of these weapons are still in development, but others are already proving their potential. So which one of these caught your interest the most? Please drop a comment below. And if you enjoyed this deep dive into NASA's impact on firearms, don't forget to hit like, share with your friends, subscribe for more content, and click that bell icon so you never miss an update. Thanks for watching. And as always, this is Threat to Survival. Prepare today, thrive tomorrow. Embrace the threat to survival.